some additional set notation concepts. We've already learnt the addition rule. It's important to note that for problem-solving purposes, especially in Venn diagrams, the addition rule works for the number in each set as well as for the probability of each set. So the rule can be written for the probability, or the rule can be written for the number. We'll come back to that one, because what I also wanted to look at very quickly was 11a from 8c. You've been asked to find the probability of A and not B. Now, to be honest, I would, if I was having trouble with a question like this, tackle it with a Venn diagram just so I could envisage what's happening. Because you are allowed to put, I didn't give much space there, you're allowed to put the probabilities in a Venn diagram, as well as putting the elements or the numbers of elements. So the probability of A is 0.5, the probability of B is 0.4, and I know those need to add up to 0.8 in those three regions there. So I would use the standard addition rule to work out the probability of just A and B. So that's what we're finding there. Substitute our values in. So the probability of A and B, solving that, is 0.1, which I completely haven't given enough space for. Now from that, you can, if you want, get the probability of only A, 0.4, or only B, 0.3. And the probability of, if you wanted it, not A and not B, remembering that that is the probability of not A or B. So that's 1 minus the probability of not A or B. Oops, sorry. That's 1 minus the probability of A or B. So that's 1 minus A or B is 0.8. So this is 0.2 out here, which we could also have worked out because this whole thing needs to add up to 1, and we had 0.8 in these regions here. So you don't actually need a Venn diagram to solve this, but it really helps to visualize, at least it does for me, because I want the probability of A and not B. And looking at a Venn diagram, it's very easy to see that that would be the probability of A minus the probability of A and B. So that will be, and in fact we can see it right there, it's 0.4. But if I wanted to show working, or if I wasn't using the Venn diagram, this is helping us visualize what's happening. So that would be, of course, 0.5 minus 0.1, and it's obviously, as we can see, 0.4. Sorry, checking the time. I didn't want to make this a long one. Now, what I also wanted to do was look at the use of the addition rule for this sort of problem, which is actually from the previous exercise, question 13. And it's when you're given the neither and the two totals for a Venn diagram, but you're not told both. Now what you can do is a two-way table, and it will work perfectly well, but what you can also use is the addition rule. And use it with n. I want to find n and b, but I've got all the other information. Everyone likes something, so this is 12. Oh, sorry about the bell there. The number who like cakes, I'm assuming cakes is A here, is 7. the number who like tarts is 8 minus n, a and b. So that's 12 equals 15 minus n, a and b. So the number in a and b is 3.